Hi guys, this is lesson 1 in unit 10. Today we're going to talk about arithmetic sequence. Let's start by defining the word sequence. A sequence is a list of numbers in a particular order, and most of the time you will see a sequence named or called by a sub n. Each number in a sequence is called a term. The first term in a sequence is symbolized by a sub 1. The second term is symbolized by a sub 2, and so on. Let's take a look at this example. We have a sequence 1, 5, 9, 13, and 17. The first term in this sequence, or a sub 1, is going to be the first number listed in the sequence, which is 1. A sub 3, or the third term, is the third number in this sequence, which is, in this case, is 9. A sub 1 plus A sub 3 means the first term plus the third term. So what I need to do is to substitute a sub 1, or the first term, by 1, because that's the first number in the sequence, and to substitute a 3, or a sub 3, or the third term, by 9, and find the answer, which is 1 plus 9, which is 10. A sub 4 minus a sub 2 divided by 5 means the fourth term minus the second term divided by 5 is. So I'm going to switch the fourth term, or a sub 4, with the fourth term in the sequence, which is 13, minus the second term in the sequence, which is 5, divided by 5. Now 5 divided by 5 is 1, and 13 minus 1 is 12. And that's the final answer. Square root of a sub 3 means square root of the third term in the sequence, which is in this case 9. And square root of 9, as we mentioned before, or we learned in previous lessons, is negative 3 or 3. So we have two types of sequences that we're going to learn in this unit. The first type is called the arithmetic sequence, and the second type is called the geometric sequence. So let's start by the arithmetic sequence. Today's lesson is all about the arithmetic sequence, what we need to know about them, how we can work with them. So the first thing is the definition. A sequence of arithmetic sequence is a sequence of terms such that the difference of any two successive terms is a constant number. That is called the common difference. What does that mean? That means that if we have a list of terms in a sequence, the difference between any two consecutive terms is a constant number. Let's take a look at this example. We have this sequence 2, 0, negative 2, negative 4, negative 6, and negative 8. And this is an arithmetic sequence just because of the fact that the difference between any two consecutive terms is constant. So 0 minus 2, that's a negative 2. Negative 2 minus 0, that's a negative 2. Negative 4 minus negative 2, that's a negative 2. Negative 6 minus negative 4, that's a negative 2. And negative 8 minus negative 6 is negative 2. So as we can see here, the difference between any two consecutive terms in the sequence is constant, which is -2. So the most important information that we need to know from the sequence is that the first term is 2 and the common difference is -2. Now let's talk about the rules for arithmetic sequences. We have two rules that we need to know for arithmetic sequences. The first one is called the explicit rule, and it's also called the general rule and the nth term rule. And the formula for that rule is a sub n equals a sub 1 plus n minus 1 times d. Now, a sub n can represent any term in the sequence. A sub 1 is the first term, n is the order of the term in the sequence minus 1, and d is the common difference. So to be able to use this general rule, we need the first term, we need the common difference, and we'll be able to find the general rule or the nth term rule or the explicit rule for a sequence. Now the second rule is called the recursive rule. And in this rule, the formula is a sub n equals a sub n minus 1 plus d. Now in this rule, we'll find out that to get to any term in the sequence, I need to know the previous term plus the common difference. So to be able to write this recursive rule, all I need to know is the common difference in the sequence. Let's put all this into practice. Let's take a look at this example. List the first 5 terms of the following sequence. We have, looking at this sequence, we have the nth term rule or the general rule that says a sub n equals 3 plus n minus 1 times 2. If we look at the formula and look at the format of this nth rule, we'll find out that the first term in this sequence is 3, and the common difference is 2. 2 is the common difference. That means to be able to list the first 5 terms, I need to start the sequence with 3 and add 2, because 2 is the common difference, to get to the next term, which means it's going to be 5. And 5 plus 2, that's a 7. 7 plus 2, that's a 9. And 9 plus 2, that's 11. And these are the first 5 terms of the sequence that is represented by this nth term rule. Now let's take a look at this example where we have a sub n equals a sub n minus 1 plus 6, where a, or the first term, equals to -2. Now this is the recursive rule, which means in this case 6 is the common difference. To be able to start this rule, the sequence, we need the first term, and it's given in this example. So the first term is -2. That means all I need to do to get to the next term is to add the common difference, which is 6. This means that the next term is 4. The term after that is 4 plus 6, which is 10. Plus 6, that means the fourth term is 16. And then the last term is 16 plus 6, which is 22. Now let's take a look at this example where we have to write the nth term rule for an arithmetic sequence explicitly and recursively. To be able to write the rule, I need to think about the first term, and I need to find the common difference. Looking at this term, at this sequence, I have 1, 5, 9, 13, and 17. That means the first term is 1, and we can find the common difference by subtracting a term from the following term. So that means 5 minus 4, 5 minus 1, which is 4. That means I need to add 4 to 1 to be able to get to the next term in the sequence, which is 5. 9 minus 5, that's a 4. 13 minus 9, that's 4. And then 17 minus 13, which is 4. So the common difference in this situation is 4. Now, to be able to write the nth term rule or the general rule explicitly, that means I need to follow the formula for an, and then I need, which is equal to the first term, which is in this case 1, plus n minus 1 times the common difference, which is in this case 4. Now, I can simplify this even more by distributing the 4 into the parentheses. So I'm going to have an equals 1 plus 4 times n, that's 4n, and 4 times negative 1, which is negative 4. So the sequence can be expressed explicitly in this case as an equals 4n minus 3. Because we have like terms, negative 4 and 1 are like terms. When we put these two like terms together, we end up with negative 3. Now, to write the formula recursively, I need, to write the rule recursively, I need to follow the formula where I have an equals the previous term, which is an minus 1, or a sub n minus 1, and then add the common difference, which is 4 in this case. And I have to include or mention that a sub 1, or the first term in this sequence, is 1.